So orchestra people, I hope you're having fun at rehearsal, but this is your homework for today. There will not be new homework tomorrow. So whether you make that choice or orchestra people will probably make that choice of not like getting yourself freaked out about it tonight, because you can work on it tomorrow as well, but 33 through 38. Hi, orchestra people. Tomorrow, I had to kind of flex around my plan a little bit because of orchestra and Friday canteen and all that stuff. Tomorrow, with our half-hour short classes, you'll get your test back. Again, they will not be in math yet. And some of you still need to finish, and I've caught a couple of you at like AR extensions and had you work on it a bit more. I have provided feedback with what you have done right now. And I'm still kind of making this plan, but what I'm thinking right now is I'm going to have you guys assign yourself what mastery grade you think it would deserve. Now, if you are not done and just need more time to work on it, we'll use tomorrow to give you some more time. If you have questions, I'm like, wait, how did I miss this? I really thought I was right. We'll go over those sort of things. So we'll just take all of tomorrow to like work on, finish up, take questions, revise. So like if you're like, man, yeah, I didn't know this as well as I thought, I should probably give myself a progressing, but I can do these revisions if I like look in my book or look at my notes or whatever else. That's my plan as of right now, is that tomorrow we'll go over those. You'll give yourself your own mastery grade. There's a lot of research on self-grading or self-assessing being really beneficial for like middle school and high school kids. So it's not like I got some grade and I don't exactly know why. It's I got this grade because I felt that I didn't know this well enough, right? Like I gave myself this grade because I did not know what I thought I did. That sort of stuff. That makes kind of sense. You guys can totally move those desks if you want. You're sitting at a very awkward angle. I don't know who moved that group. This group is totally in the wrong. Yeah. And we were only working in pairs last class. I'm about to have to like stop letting you guys use this because people can't stop ripping pieces off of it. All right, so today we're working with percentages. My hope would be that we do this for about 20 minutes, and then I can give you guys some time to work on the homework. Who can remind us what we use scale factors for? We talked about it yesterday. There's a little reminder picture up in the puzzle piece at the top right here. What is a scale factor? George?
It's when you have like a shape and it's the number if you're like decreasing all the, I don't know, it's like decreasing something by a percent or increasing something by a percent.
Okay, not always percent.
Not always percent, but like a number.
You're saying percent because that word's up here now.
Yes.
Yeah, there's more, Mallory.
It's like a multiplier.
Yeah, it's a multiplier that we're going to put on something to change its value, which could potentially be change its size, right? If we're talking about a shape. Or it could be change its length, or change its circumference, or change it. It's just to change something, right? It doesn't have to be a shape. It doesn't have to be a size. But a scale factor is a multiplier that we use to change something. Percents are the same thing. If you know that something is 20% off, what percent is on? 80. Right? So if you want to find out the new price that is 80% of that object or of the original, your multiplier would need to be what? Don't say 80%. What would we use as our multiplier to get the 80%? Like that? 0.8. Right? The number we actually use would be 0.8 or 8/10. Right? Because 80% is 80 hundredths, which as decimal form would be 0.8. So, I want you guys to work through these problems. I might just give you a little bit of time, try a little bit of independent working, especially because we're smarter today. And we can draw diagrams for this, right? So if I told you that I was going to buy something that is 80% off, and maybe it was initially $120. So in reality, my object is $120. But I now know that it is 20% off, which means I have, and you can draw these a little bit differently if you decide to. This is all up to you. 80% on. So my question becomes, what do I end up having to pay? Right? Because this, I don't pay this amount out here, but I do pay this. So this is how we can draw a diagram to help us represent the percent model. The entire thing is the whole price originally, or whatever they were trying to get for it. Then I'm going to find my discounted or potentially increased price. Let's say instead of taking 20% off, I'm trying to raise the price by 20%. So maybe then my model becomes that I extend this an extra 20%, and how do I deal with that? Or what would my multiplier be there? You may use calculators for this work. So if your team doesn't have one, I would potentially go get one. And we probably going to give you a few minutes to just work through 27, 28, and potentially 29, and then we'll come back together. So let's say, hang on, I'm going to give you guys until the 10, so about 7 minutes, till 10:10, and then see where you're at then.
Okay,
Does that sound all right?
What's the page number?
Who's got page number?
390.
390? Man, we're burning through this book real fast. 390. So, orchestra people, to not waste the video, I'm going to pause it. So if you end up working on this on your own, you should pause this. I will restart the recording when we come back together to work on 27, 28, 29. But if your team takes 3 minutes per problem, now I might give you guys until 15 to work. Well, I'll check in around 10. I'll check in and see where we're at. Have at it. Alrighty then. If we look at 27 here, we got Hugo buying a bed that is 60% off the original price, which I could go off on a tangent about the mattress industry and how many people have to make money off this nonsense. Then it gets put on the truck from the factory to the store and then put on another truck from the store to your house and all the middlemen and yeah.
Can't give the husband just to the store. Can you just pick it up and put it on your own truck?
You could, but you'd have to own your own truck and it'd have to be big enough to get a bed home, and you'd have to want to put a bed on your truck and then drive potentially on the highway where beds like to fly off of vehicles. And it's a big old thing.
If you disassemble it into pieces.
We're talking like mattresses.
You can't disassemble a mattress.
So, all of that to say, beds get real expensive. 600, what is it? No, 245 is cheaper than you'd probably find a bed for. So this isn't really a realistic problem. I mean, you might find a smaller one on the cheaper end, but a lot of them are pretty expensive because you sleep on it every night of your life. You spend a third of your life in your bed. If you get 8 hours of sleep every day, that's a third of your life. So, how do we draw this? How do we model this? How do we do it? Anyone confident enough to come up and show us what you did on your paper? How you figured out the now price of the bed? You're not confident enough to come up, but would you describe it to me? Or were you saying no to me or no to her? So, do you want to describe it? You put your hand up, I'm confused. Okay, so what'd you do? I heard you guys talking about drawing a number line.
We did not do that.
Okay, tell me what you did.
Okay, so we made
The thing?
the thing that looks like a number line. Yeah.
Okay.
Yeah. So we took 245, and then we took 60%, and we made it 0.6%.
Right, so I'm going to make that a little over half. That might have been a bit much. But that's 60%, right, or 0.6, which, what did that come out to give you when you use that as your scale factor?
147.
So is that what the bed costs now?
No.
Oh, this is the off. Right, that's how much is being discounted. So wait, what percent is this?
0.4.
Yeah, 40% or 0.4, which means then if I use, actually a quicker way to get to our answer, everything you did is correct, but a quicker way is use this as our scale factor, since that's what we're going to pay, and we end up in the end needing to pay $98, which means they just want to get rid of it, right? But they're probably still making money. Even when a store puts something at 60% off, they're probably still making money. Maybe if it's been there for way, way too long, they will take a loss. When you take a loss, if you just want to get your product out of there and try to get some money back, you're not going to get all your money back. You just want some instead of a pile of things you don't want. right? I don't want a pile of beds sitting in the back. I'd rather make about $100 off each of them and get rid of them.
Has there been any time in market history that they have going for a very long time that they just like 100% off for free?
I mean, I'm guessing there's probably been a time or two when stores are like, okay, if you buy this, I'll give you that for free because we just want rid of it. But they probably won't just give something away completely free. They probably use that as an incentive with something else. 28. Now we're going over 100%. And this gets weird. So the book gave us a little model to use with it. We have our 100%, but then we go beyond by 6%. Which means what percent am I at now? Simon? Did you hear my question? What percent are we at now? 6% more than what we were last time. Yeah, we're recording now. If I had 100% of my salary and I gained 6 extra percent, I got a raise. Yeah, we're at 106%, which means what is our scale factor? What do we multiply with? Go ahead, Simon. Ooh, close. 1.06. Now, you could just multiply by 0.06, but then you'll still have to do an addition. Like, I would still have to add it. If I know that this was $3,000, we could multiply by 0.06 and then add that on to get our new value. But if you multiply by 1.06, you immediately get the new salary, which is what? 3,000. 3,180. Any questions on that? When we get a raise or when we gain above 100%, we should always have more than what we started with. That should be kind of straightforward. My value can't go down if I got a raise. And 29, Mirana, I don't know. What just call her? Miranda. I'll take out the D and just say Miranda teaches gymnastics at summer camp. Gets paid $12.50 an hour. She gets a rate. Whoa. Wait. What? Miranda is offered a raise of 100%. Who can make sense of this for me? Give me hands. I'm just taking volunteers today. Braden?
It's kind of confusing, but a raise of 100% would be just kind of raising her original pay. So if it gets $12.50 per hour, then that would be 25.
Yeah, if you go up 100%, and the trap door they're trying to set here is, well, 100% is what I had. They're not offering just to pay you 100%. They're offering to raise you 100%. That's like doubling down, right? So exactly what Braden said. We end up with doubling this, and we would get paid $25 an hour, which is good pay. Now, if she's offered a 75% raise, how could we figure that out? I don't know if there's a super duper easy way here.
1.75.
If we want to do a one-step scale factor, we take my 100% and add 75 more percent. My scale factor is going to be 1.75 times that 1250. This isn't very nice because like 25% of 12 is $4, but 25% of 50 gets a little messy, and you're actually going to get an answer that probably isn't in money form. Like it probably has 3 decimal places. Yeah. So you got to round it, right? So our answer comes out to be what? 21.88. Mallory, what do you got back there? 875. You can't get paid that, right? So you wouldn't put that down for your answer because it doesn't make sense. although that's right, it's not, because it's money, and that spot doesn't exist. So we would actually write our answer, as 21.88. Round up, because that's 5. Questions on that? And this is essentially the same thing again. Just if they instead give you the ending, so this is just like find the mistake, one of those problems. Liam's trying to solve for x and he multiplies by 0.14. That's wrong, right? Because my x section, I want to give you guys a few minutes to work on your homework, that's why I'm trying to rush. My x section relates to the other percent that is not the 14%. So 14% would give me this section, but then I could do subtraction to figure out x if I wanted to. But he just added an extra step. This is not technically correct. We would need to subtract from the 72 to actually find that answer. Any remaining questions? Scale, factoring, with percents. We have 10 minutes left, which was my plan. You have this time to work on your homework. For anything that you are asked about in your homework, I had one of your classmates ask me, Mr. Hudson, what is interquartile range? I've never heard that word before. And I said, what can you do with words you've never heard of? And he said, look them up. And I said, great, you have a way to do that in your math book. And he said, oh, yeah. Like, I believe on one of your recent homeworks, the word interquartile range, IQR, anybody, does that activate anything in anybody's brain? You can look it up in your glossary and it gives you an amazing definition and everything, like an example and everything else. So I'm not going to try to, in like 10 or 15 seconds, explain it to you. Look it up. If you don't know what something is, look it up. You've got an amazing resource with this textbook. So there's 33, 34, and the beginning of 35 if you just want to look up here to do your homework. Or I appreciate that most of you have textbooks out. I really do appreciate that. And then I'll put on some music so we can just chill while we do our homework. Orchestra people, hope you had a great day.